the desk of Ladyada.
Hey everybody, and welcome to the desk of Ladyada. It's me, Ladyada, with me, Mr. Ladyada. We're here at Hacker O'Clock, here in the Adafruit home headquarters.
That's right.
Where we're doing some electronics and getting some stuff done in preparation for the week.
Big week ahead, like every single week. We got a bunch of product coming out and more. This week, all our shows are in effect. The only difference this week is I think JP's doing show and tell this week.
Yes, he's on.
All right. So,
okay.
Ladyada, what is on your desk?
Well, I've got a lot of new products. I thought I would just show them off because I got the testers done. So let's start with, let's go to the overhead and I can show off some of these testers. Hold on. Get everything all nice and set up. So this is, all of our TFTs, and we have a lot of TFTs in the, hold on. 1 second. Okay. We have a lot of TFTs in the Adafruit shop, and, I've been trying to come up with like a new way of connecting to TFTs that's a little bit like Stemma QT, except for, instead of I2C, it's for SPI. And I like DF Robot's little flex connector. It's a good idea because you can't do it with a JST, even an SH connector. It's just the pitch isn't fine enough for all the pins, because for stuff like e-ink displays, you need like SPI and you need a bunch of chip selects. And for some screens, there's a touch screen, and there's an I2C touch, and there's like a SPI touch. So it's like basically you need like 16 to 18 GPIO to control any TFT display, and we do a lot of TFT displays. So this is I think I've shown off this kind of round racked 1.47 inch TFT display before. So we made the breakout for it, and we added, in addition to the SD card slot and the normal breakout, we also have the little EYESPI connector, which means we can flip this up to easily attach a flex connector, so that people who want to have the screen separate from the board, you don't have to like wire or solder together a whole bunch of connections. And then it also makes testing really easy because we have like one tester, and it's the same flex connector for each time because the flex connector is standardized. So there's this 1.47 inch one, and then its big sister, which is this 1.9 inch screen, same resolution actually, pretty much, but a larger, physically larger screen. And this one, it has a flex connector too, so it's kind of constrained where you could put the EYESPI contact. So I put it up on the side here. And this one, same basic idea. It may not have the right SD card file on here. No, that's okay. Same idea, it displays an image, and then it pulses the backlight. So, this tests everything. You've now tested the SPI port, you've tested the TFT, you've tested the SD card, you've tested sending data from the SD card to the TFT, and you're testing the backlight by pulsing it. So it's a very easy way to tell that the backlight PWM is working. So, this is kind of fun because it's like, I think it's actually make testing a little easier because you don't have to hold down the screen. You just put this, flip top connector. And I love these flip tops. They're so much easier and less likely to break than pull out style where it's top contact. So I like bottom contact FPCs as much as possible. So, like having everything be bottom contact, I found less likelihood of the little ears snapping off, which is always kind of sad. All right, so that's those displays. Also did a revision on, so this is a new time of flight sensor from ST that just got released, and I got a real, let's see, why won't this lock? It used to lock, no, it doesn't lock. This is the VL53L4 CD. There's like the VL53L1, VL53L0. They did the VL53L5, and then they kind of backed it off and did the 4. And the 4 is like the other time-of-flight sensors, it uses a laser and it measures the picosecond refraction off of a target. For this one, it has less range. Instead of 4 meters, it only does like 1.25 meters, but it can do much closer readings. So the other ones like to have at least 10 millimeters to do the readings. This one is actually happy to do as little as 1 millimeter. So it's really good for like ultra close-up ranges. Do you know why this isn't locking anymore?
No.
Okay, well, whatever. We'll get another one.
I think maybe we can upgrade.
It does, and then it stops.
Yeah.
I don't know. All right, so that's that.
I think it might be time to upgrade the overhead setup anyways.
This
because
is
the chips
many
are
years
getting
old.
smaller.
Yeah.
And our screens are getting bigger.
I
So
do like
think-
the new one. The new one's kind of nice.
Yeah, we use that on the Ask an Engineer setup.
Yeah.
Okay.
Okay.
Well, that's going to be on our list of things
We'll do that this
to
week.
get.
Okay, so that's these testers, and then the last tester I worked on this week is this says ESP32S2, but it's not. It's the Pico ESP32. So these PCBs are coming in. I had to fix a couple little things, and then it was Chinese New Year, Lunar New Year, so PCBs were really delayed. But they're coming in, and so the Pico ESP32 is going to get made. And I'm using a Raspberry Pi to do the test procedure. I like using a Raspberry Pi for ESP32 because I can run ESP tool. And, we do have ESP tool on a microcontroller. Like I have written that. So it's like you can use a microcontroller to program an ESP32. The problem, though, is it doesn't use the... I didn't port over the stub loader, which is like this compressed way of compressing the firmware before uploading. And so even though it's slower to use a Raspberry Pi than a microcontroller, it's faster because if the code you're uploading is big enough and I don't compress it, and especially with this where you're limited, it's like the flash write speed is limited by like the baud rate a little bit. Turns out that using a Raspberry Pi works quite well. So this fits in here, and then it's got a little thing. It says press the button.
Yeah, we're gonna have a video of this.
Yeah,
going
video,
up
but
soon.
it uploads the test code, and you can see kind of at the bottom here, it's uploading to, and then it tests all the pins, and then it tests the Wi-Fi signal to make sure that the Wi-Fi signal is good, and if it passes, you get this green text. So 17 seconds for tests, that's pretty good. And then when it's done, the program I load also does like a little rainbow swirl, and it does a Wi-Fi scan. So it's like a nice little ready to go out of the box test for the ESP32 QT Py. So that'll be cool. And I love that this chip has PSRAM as well as 8 megabytes of flash. It's it's gonna be like the smallest but most powerful ESP32, and I think, it's like I showed you can run Doom on it, but I think it can do a lot of other stuff too. Great for IoT.
All right. So I think on the previous thing that you showed, what's the precision of it?
For the distance sensor,
Yeah, it must be
I don't
that.
remember. It's like 1 millimeter or something.
That's good.
Okay, cool. And then lastly, so it's the stuff I've been working on. I got a couple more things. Oh, I've got this camera module. So getting back to some camera stuff, and there's these off-the-shelf camera breakouts, and I wanted one for my own because I wanted to experiment with different cameras, but also there's a couple things about off-the-shelf camera boards that I didn't super like. They look like
Do you want
they
to
look like
answer a
this.
question about the QT Py ESP32 now or after this?
No, it's fine.
Okay. Will the QT Py ESP32 have a GPIO pin to turn off quick for sleep, ultra low power?
It can do ultra low power, but you can disconnect everything, and I think I got down to 55 microamperes. I do have a graph that I measured, but you can turn off the NeoPixel and go into deep sleep, and that's as deep as it's going to get.
Okay. Cool. All right. So
Okay.
camera boards.
So one thing I don't like about the camera boards is they always come soldered with straight headers, and so you can't do right angles. That was a little annoying. And second, there are some cameras that have autofocus, but you need to connect to pin 2, and on these boards they don't break out pin 2. So I was like, fuck it, I'm just going to design my own. And I also made it so you can plug it into a breadboard, which is another like nitpick for me. This is the, if people remember, I was working on the autofocus cameras. This is an autofocus camera. So this will work with any like OV module, including the autofocus type. The pinout, thankfully, like e-inks, is totally standardized. And to test it, I'm actually, can you go to the computer? I'm running this demo that is, it's quite nice. It actually comes with the ESP32. It's called Camera Web Server. And what's nice is it like auto detects what camera chipset, whether it's the OV2640 or 5640 or whatever, like there's OV766 or something. And it will, so this is a live stream web server. And you can also go, maybe get a little bit bigger. It'll be a little slower. So you can see I'm like testing, you know, if I can like point to it like Phil, hey. So it's behind the scenes. You can point at me. Hi. So it's a really good way of quickly testing that everything works and the quality of the camera, and you know there's no weird color artifacts or jitter, so I know that I'm good to go. So this board also got sent out. Oh, I also have an external clock generator, and I put like big holes on the back for heat sinking, because these camera chips actually get a little bit warm, especially as you're streaming a lot of data very quickly. And you can do other effects. So you can change the exposure to all the way down to all the way up, so it's like really overexposed. And then you can do sepia tint, negative. It's kind of cool. Hey, or negative land. So good stuff for testing this camera module. So the camera module breakout's ready to go. So that's cool. Just doing that.
All right.
Unplug this. And then finally, we did pretty much everything we're going to do with floppy stuff on the Shugart drives. So we got like Mac stuff working. We got 5.25-inch drives working, 3.5-inch drives. We got the floppy drives from the laptops working. So like kind of everything, like, you know, you can spend forever trying everything, but we pretty much did a proof of concept. And then Jeff also did like streaming mode, so we can like stream data directly from disk. So all good things. So the next step is we want to extend it to now support Apple II disk drives. So I got this Apple II drive and I put it in a clear case. So maybe we can go to the overhead real fast. So this is an Apple II drive. You can see. But we removed the metal case and replaced it with this clear case, which is kind of neat because you can actually see the. So this is a diskette here. So this is the slot. You can see the diskette coming in here. And what's interesting about Apple II drives is they're actually the same Shugart mechanism as 5.25. It's this 5.25 disk, but they basically removed a lot of the stuff that basically to reduce costs. So like some things like on the Shugart drive, the interface lets you set the direction and then step in and out. And there's also like, you know, so there's like a stepper motor controller. On the Apple II, you do that by hand. You actually have to like manually control the 4 phases of the stepper motor to move the head back and forth through the tracks. And that's also can be used for like some hacky things. Like you can write while moving. So like in on the Shugart drive, I don't believe you can step while writing. I think like once you're writing, you're like writing and like the drive will not do anything else while it's writing. But on the Apple II, since you have control of the stepper motors, you can like start writing data, those flux pulses, and you can like spiral the track out if you so wished. It's kind of interesting and neat. But the good news is that like other than the stepper motor stuff and lack of an index pulse, the concept is still the same. You've got these flux pulses, you read them, you write them. They're GCR, like similar to the Mac 400 and 800K. You know, there's very similar signals. There's just this new analog board that does some different stuff, and the power supply is a little different. And so that's actually going to be the great search.
All right.
Is there any questions before we?
Yeah, let's do a couple questions and then we'll bounce over.
Yeah.
Some folks want to know about some button box tutorials. I said check out learn.adafruit.com. Same thing with robotics. What is this small monitor that you use? Does it house the Pi also?
Oh, that's the Pi TFT.
Okay.
Yes, we sell that. That's the.
All right.
add-on.
Someone was watching a YouTuber the other day, and the person says, "Why doesn't CircuitPython support email?" It's Python. It does.
You could add email. I mean, we have the reason we don't do. There's no email client. Is email has changed a lot in how you send and receive it. Like it used to be, you could just like telnet to a port 25 and send, and now there's a lot more to reduce spam. It's just a little bit more complicated. So we don't really have a built-in mail client or writer.
Yeah.
Because it isn't how it used to be.
Python,
Believe me, it used
so
to be really easy.
Yeah, let me.
I have an old Apple. I have an old Arduino demo that used to do it. You just connect to port 25, say hello.
Yeah.
Send mail, but you can't really do that anymore. Just like you can't really red box anymore.
Yeah. You can
They took
kind
that
of
away.
find some libraries out there and probably port them over, but.
Yeah.
Anyways, hang out in our Discord and let us know what you would do with it, and also to post up in our forums, because it'd be interesting to see. Maybe there's something we do with Adafruit.io to help out with some of the stuff.
You have to like authenticate. It's just it gets very complicated. Twitter used to be very simple too. You could just like search.
Can't do it anymore.
You can't do it. You have to authenticate, and you have to use OAuth, and it's like.
Camera question: do you plan on making a board with the camera to plug in to the headers and then a microcontroller and other pins, so plug and play?
Yeah, I think so. I mean, like, there's also the Kaluga board I showed you that has a lot of boards that can do camera, have a little camera port, and there's a standardized pinout.
Okay, where can I get a side push button like the reset button on the D1 Mini compatible with KiCad?
I don't even know what the D1 Mini is.
Yeah. Okay.
We've done
All
some
right.
great searches on right angle switches.
Let's do the great search.
Okay.
Where in the world is that part I need? The great search with DigiKey.
Every single week, Ladyada user powers engineering to help you find what you're looking for or things that you don't even know you're looking for yet on digikey.com. Ladyada, what is the great search of the week this week?
Okay, so this week I'm going to be interfacing to this Apple II disk drive, which is in a beautiful clear enclosure.
That's cool.
And the Apple II disk drive has a slightly different control mechanism for how you control the drive and read and write from it. And it has this analog board. And the analog board has... Hold on. So you want to go to my computer so I can show the schematics. This is the schematic for the analog board, the disk interface. And you'll see it has a negative 12 volt power supply. So it has plus 12, there's VCC, which is 5 volts, and negative 12. And that's a little unusual. Well, I mean, at the time it wasn't unusual because transformer-based power supply, it was really easy to split the tap and then you can generate a negative voltage. But with digital electronics, we don't tend to have negative power supply rails really as much. So the good news is that, most disk drives that I'm used to working with, so here's the 5 volt supply. The 5 volt supply and the 10 volt supply are used for logic, and there's a stepper motor, probably that's the 12 volt. And then there's a spinning motor, probably either 12 volt or 5 volt. So 12 volt and 5 volt supplies are high current. They're going to be like an amp or two because you're going to drive a motor with them and a lot of these logic chips. The negative 12 volt supply, however, let me find it, is used for a bias. Hold on. I have like 500 images and they're all blurry. Okay. So this is where the negative 12 volt supply is. It's right here. And it's used as part of this analog circuitry, which filters the pulses or like biases the read head. I'm actually not 100% sure. I have to look up what the MC3470 does. But this is the only place that the negative 12 volt appears. So, the potentiometer, R28, and, I looked on this board to look at R28. And R28's not, it looks like, you tweak and adjust it to set it looks like the jitter, adjust the jitter for the analog board. So here, this is the tech instructions for this board, and they say, okay, look at this trigger pulse. I guess this is maybe the bias for the trigger, where like, it there's some timer, and then it like reads the timer and it uses the pulses to like generate the pulse train or synchronize with the pulse train that comes out of the diskette. So there's a potentiometer you have to adjust. So you do need to give it that negative 12 volts, especially, you'll get weird results. If not, maybe you'll not get some good reading results. You might get errors on write. So you do want to have a negative voltage, and you want to have that voltage at least be consistent. So we have to generate a negative 12 volts. And again, for digital electronics, we've done boost converters and we've done linear regulators, so you can like kind of move up and you can move down, and you can use buck converters. But now I want an inverter. And I'm extremely lazy about this inverter because it's not a power supply, it's like a bias supply. I don't need an amp of negative 12 volts. If I did, I would actually probably get a custom power supply to do that, or put in a big boost converter, buck converter that does inversion. If I only need, a couple milliamps, because it's a 10K potentiometer, I'm going to look for a charge pump inverter. And charge pump inverters, the reason I'm a fan of them is because if you remember your MAX232, this is a kind of a famous part, not used as much anymore, but was famous for if you had an RS232 interface, which all electronics used to. You would use this and it would convert your 5-volt logic, or there's a version for 3-volt logic, and it would do this neat thing where it was like, hey, since it's not a power supply that you need negative 10 and plus 10, but you just need it for biasing, for signaling, not for powering, it would, there was a built-in charge cap. You would put some, 1 microfarad caps on the outside. It would convert the 5-volt to 10-volt, and then do an inverter to get you 10-volt to negative volt. So, one, I could probably get away with using a MAX232, but I kind of want to not cheat and use a chip that isn't designed for it. And second, I might actually need negative 12. I want it to maybe be perfectly balanced. So this was actually kind of interesting because I wasn't actually sure how to find this because, it's a weird part. But I think I searched for, it's under regulators. So it's considered a DC-DC switching regulator. And it's actually called ratiometric, which makes sense because you're not regulating it, you're just flipping it over. So let's look for active, ratiometric, or inverted, because you can also get inductor-based converters. We want only one output, and we want to make sure it can give you negative, positive or negative. Well, I'll just say positive and negative. And voltage input max. Wait, I messed something up. Let me start over. This was very confusing. So, hold on. I want negative. I might have to go back from the part that I found and then go backwards. So positive or negative, one output. Voltage input max. Okay, so for voltage input max, because I want to generate 12 volts, I need it to be able to take at least 12 volts. So I'm going to select all of these. And let's see what I get. And then I don't care about adjustable or fixed because I can tweak that. And yeah, I got a bunch of these parts, and then I did surface mount only because it turns out there was a lot of through-hole parts. And a lot of things were out of stock. So the first thing I found was there is this very popular part that's been used for a very long time called the ISL or ICL 766X, and there were quite a few of these, and these are ancient. These have been made since the beginning of time. So you can use this part most likely, and that comes in a lot of different manufacturers. It's kind of a jelly bean part. So if you search for, let me open up a new page. You look for ICL 766 to get all the alternatives under the switching regulators. Yeah, you'll see. So this was made by like Analog Maxim, by Harris, by Renesas. So lots of different options. Came in DIP and also SMT. So this is one version. There's also the 7662. So there was this whole family. However, I wanted another alternative because this was a little bit of an older chip, and there were a couple available, but it's sort of I was a little anxious about it. So the other one I found actually was the TC1044, and this actually there's also the TC1054. 1 second, 1054. Is this under linear regulators? Hold on. Let me look at my history. This was, sorry, the LT 1054. Okay, so the LT 1054 was a different charge pump inverter. So this was available from TI and Analog, and the good news is this one was a little bit less expensive, but it came in a 16 SOIC, so it's much larger, but it's a much more modern chip, and the pricing was pretty good. It's basically like $1.50 or so, and it can do either doubling or negative. So it's kind of got this like weird voltage output, negative VN or 2 VN. But the good news is that it could take up to 15 volts input. So this was actually what I ended up picking for what I think I'm going to use. I'm going to get some of the samples of the ICL 7660. But one thing that's interesting about that part is it's so old that it actually started getting more expensive than the modern part. Like usually you'd think like, oh, an old part like, TL074 or something, so, some op amp. If it's like a couple of decades old, it'll be really inexpensive. It's made so much. But one thing I've noticed is like during the silicon shortage, sometimes there's this like weird like it's like there's like a dip where it's like very new parts are very expensive because you can't get them, and very very old parts are very expensive too because they're like not really made anymore, and so the people who need them are like desperate to not. Like, you have some like mil spec design and you're not going to change this component. You absolutely need to use this component for the rest of, human history. So you're desperate to get it. So there's like this nice middle ground where you're actually going to get better pricing on parts that are like about 5 to 10 years old. So even though this is a more modern part, it actually ended up being less expensive than the ICL, which was like, for some reason, like $5, for this like multi-decade old component. So the ICL probably works really, really well, but I think I'm probably going to go with the LT 1054. And I also learned a little bit about product history and pricing, I think, along the way. But what's actually kind of fascinating is there's a lot of boost converter, like the charge pump inverters, for 5 volts, but once you get to 12 volts, it's actually kind of a little rarer. But this one should absolutely do the job quite nicely, and I'll pick it up. And it's a bit chunky at 16 SOIC, but sizing is not as important. There's also a Maxim part that I saw that goes up to plus or minus 40 volts and a TDFN, much more expensive. But if you need to generate like a negative 60 volt bias, the Maxim part will do the job as well.
And that is the Great Search.
Where in the world is that part I need? The Great Search with DigiKey.
Okay, so a couple questions, then we'll bounce.
Yeah.
Literally. With all the fabulous Stemma QT stuff going on, any plans to respin the Circuit Playground Express or Bluefruit with a Stemma QT connector?
I'm not planning to respin it. Honestly, there's really no room on that board. And I'm having enough difficulty getting parts. However, it's really easy to connect Stemma QT with our alligator clip plugs. I think Another thing about the Stemma QT connector is I'll say it's for very young kids. I feel like it's a little too small for them. I think there could be a chance that they'd break it. I think that'd be such a bummer. So I just recommend using alligator clip. We have an alligator clip to Stemma adapter cable, and that way there's no risk of breaking the connector on the board.
Maybe we should make that a stacky on the product page, or just do a guide specifically about that, adding Stemma.
Yeah.
Maybe we'll do that, because I forgot about it too.
Yeah. No, I have like every combo cable on purpose.
Yeah. Okay. That's it for...
If you want to see my beautiful clear Apple II disc some more.
Yeah. That's nice. All right, and then we did this parody thing. So this is a QR code that's like the DVD bounce thing. And the reason we did that, there was a Super Bowl commercial that that's doing this too. This just takes you to Adafruit.com, but just a little bit of like a security thing. So, if this Super Bowl is going to mark the beginning of everyone just taking out their phone, scanning a QR code, and just kind of doing stuff, just be really careful, especially
watch out.
Especially with folks who aren't so savvy with this stuff. It's kind of an interesting security flaw that I don't think anyone's thought of, is what happens if a Super Bowl commercial is only a QR code. So, on one hand, we get dunked on for even talking about anything ever, but I also think we're here to educate and help. And so while this is funny, and this is Adafruit.com and it's safe, and Adafruit.com is safe, maybe other things aren't. So just be careful with this stuff, especially when you're enticed to give a lot of personal information for 25 not real dollars. Okay, that's it. We'll see everybody next week.
Thanks, everybody.